Hello everyone. I am Niharika Ibrampur from BMS College of Engineering, Bangalore, pursuing my third year of Medical Electronics Engineering. And I am here to present about the Emertxe Embedded Systems internship, that is washing machine simulation using the Pixim lab. About C, overview. C was developed by Dennis Ritchie at Bell Labs in 1972, and it is a foundational high level programming language which is widely used for system and application software. Known for its influence on many modern languages like C, Java, and C hash, and its role in developing operating systems like Unix. Some key features of C include a simple and clear syntax and structured programming approach, highly portable. The C programs can run on different hardware with minimal changes, fast execution and efficient usage of memory, direct access to the memory using pointers, and it has an extensive use of libraries and built-in operations. Some data types in the C include, we have some basic data types like integer, float, double, and character, and some derived data types which includes arrays, which are some fixed size collections, pointers, which is used to store the memory addresses and structures, group related data, unions, and enumerations, and void, which is used for functions which do not return a value. Coming to arrays, arrays are collection of elements of the same type which is stored in contiguous memory, and it is accessed by the index starting from 0. It is useful for handling lists, tables, and matrices. Pointers. Pointers store the address of variables, enabling dynamic memory management and efficient data manipulation. It is essential for working with arrays, functions, and complex data structures like linked lists. What are functions? So, they are reusable blocks of code which perform specific tasks, and they can take parameters as well as return values. There are two types of functions like the standard library functions, which include printf and scanf, and some user defined functions. Some control structures include, for decision making, we have if, else, and switch. For loops, for loop, while loop, and do while loop. For loop is usually used when the number of iterations are fixed or specified, whereas the while loop is used when the iterations are not really specified. Do while loop has a condition where it will do or perform a particular task while a particular situation or some condition happens. Coming to some jump statements like break, continue, return, and go to. Break is going to stop the execution or stop whatever statement is written. Continue is just a block of code which is helping to continue the code, and then return and go to are another two jump statements in the C programming. Some applications of C programming is it is used in operating systems, embedded systems where we call it embedded C, compilers, databases, and various utilities. It is a foundation for learning advanced programming concepts. Some advantages of C programming include, C programming is very fast, it is very efficient and portable. It has a strong community and resources. It helps build a solid base for other programming languages. Some limitations of C include, there is no built-in object-oriented features, and manual memory management can lead to errors if it is not handled carefully. Coming to embedded systems, the definition of an embedded system is, an embedded system is a combination of both hardware and software, or a combination of both hardware and firmware, which is designed to perform a specific dedicated function within a larger system. It's not a general purpose computer, but it is optimized for a particular task, which makes it entirely different from the general computing systems. There are multiple categories of embedded systems. We have standalone systems which operate independently, like digital cameras, and real time systems which must respond within a strict timing constraint, like airbag controllers, and networked systems which are connected via networks, like smart home devices, and mobile systems which are portable, like mobile phones. Coming to the components of an embedded system, so we in the middle there is a microcontroller or microprocessor or a system on chip. Obviously, it is connected to memory and an FPGA or an ASIC, and it has a software which is in turn connected to this hardware to form the embedded system. There is a DAC, that is a digital to analog converter, which is helping you convert the digital pulses or signals to analog form, and it is in turn connected to actuators. Actuators are usually specialized machinery which is connected at the output of any system to control the movement. Next, we also have an ADC or an analog to digital converter, which is helping you convert the analog signals or pulses into digital form. And this is usually in the input part where sensors are connected, which is used to sense the environment or sense any other particular measurement. We also have human interfaces which will help the users to directly interact with it. Okay, and obviously a diagnostic port and an auxiliary system for power and for cooling. The types of embedded systems. So overall, the embedded systems are divided into two types. First one will be based on the performance and functional requirements. So in this, there are four types of embedded systems. We have real-time embedded systems, standalone embedded systems, networked embedded systems, and mobile embedded systems. Based on the performance of the microcontroller which we are using in the embedded system, it is divided into small scale embedded system, medium scale embedded system, and a large scale or sophisticated embedded system. The requirements for a good embedded system is reliability. The embedded system should be able to be easily relied on, especially in very cases of very critical stages or in real-time embedded systems. Example of this could be an ECG which is being monitored on a patient, or a defibrillator which will take the pulses from the patient or the human and then give it to the machine, which is a continuous flow in medical systems. And cost effectiveness, so this is also one more very important aspect of embedded systems. And low power consumption, efficient usage of processing power, and efficient usage of memory for storage easiness. Common design metrics in embedded systems include power consumption, which is a main focus while designing an embedded system, performance of the embedded system, size of the embedded system, because mobile and portable embedded systems are more convenient, the cost of the embedded system, the safety, maintainability, flexibility, and time to market. Coming to the real-time aspects of embedded systems, you have hard real time where the embedded system should meet its deadline. This is very important in life critical applications like I mentioned before, like an ECG or a defibrillator or a pacemaker, which is continuously monitoring the signals of the patient in critical stages, and it's very important for the system to respond on time. And firm real time, which is similar to hard real time but with some different properties. And soft real time, where it can have tolerance in meeting its deadline. What is a microcontroller? Microcontroller is an integrated circuit which is capable of being programmed to perform a specific task. The design of a microcontroller normally has restrictions on its memory size, input output capabilities, peripheral functions, etc. The difference between a microprocessor versus a microcontroller. So, the first diagram is that of a microprocessor where all the components of the microprocessor are on separate chips. And in this, the storage is very less, or it is not a very efficient way of designing, but it has more flexibility. Coming to a microcontroller on the right side, so all the components of the microcontroller are designed on the same chip, which makes it very easy to design, and it is a very convenient way of designing because it saves a lot of memory or storage. But one disadvantage in this microcontroller is that it doesn't have a lot of flexibility compared to microprocessor. The objectives of the internship. So, to design a washing machine interface which allows users to select different washing modes using digital keypads and adjust water levels with long key presses, to develop a system to display the current function and remaining time and ensure the machine automatically stops operation when the lid is opened, thereby improving user safety and convenience. The microcontroller used in our internship project is a PIC16F877A microcontroller, and the pinout diagram of it is given on the right side. So it has a bus width of about 8 bits and a total number of 40 pins, which we can clearly see here, and it has 33 pins for input and output. It has 5 million instructions per second, that is the CPU speed, and 14.3 kilobytes of program memory, and 386 bytes of RAM, that is read only random access memory, and 1.256 bytes of EPROM, that is erasable programmable read only memory. Coming to the timer. So, timer is a versatile hardware module for measuring time intervals, and our microcontroller PIC16F877A has three independent timers. The timer 0 is a 8-bit timer with a 8-bit prescaler. It is used for basic timer functions and generating interrupts at regular intervals. The timer 1 is a versatile 16-bit timer with a prescaler and a port scaler. It generates a PWM signal implementing real-time clock functions. The timer 2 is a 8-bit timer with a prescaler and a post scaler. It is used for generating fixed frequency PWM signals. CLCD. So it is a commonly used display module which is used to display anything. So it can display 16 characters per line in 2 lines. It operates either in the 4-bit mode or 8-bit mode. So in our project, that is washing machine simulation, it shows the power status of the washing machine, and it shows the mode selection, it shows timer countdown as well as user instructions. Coming to the DKP or a digital keypad. So this is a set of push buttons which is arranged in a matrix format. This is commonly used as an input device in the embedded systems. It allows users to give commands like start, stop and mode selection by pressing the buttons. And in this project, the digital keypad is used to take user input for starting the wash cycle, selecting the mode or stopping the washing machine. These are some softwares which are used. The first one is MPLAB IDE. So this is used to write, compile and debug the programs for PIC microcontrollers. This is developed by Microchip and it supports embedded C programming. XC8 compiler is a C compiler which is also provided by Microchip. It is used to convert an embedded C code into a machine code, and it is used to compile the control program written in embedded C. Coming to PicSim Lab. So this is a virtual simulator which we are using to test our PIC microcontroller projects without any real hardware. It has components interfacing like LEDs, switches, and buzzers. So, in this project of the washing machine simulation, it is used to simulate the working of PIC 16F877A microcontroller, LCD display, and keypad buttons as well. These are some basic functional requirements of our internship project. First, we have the microcontroller, PIC microcontroller, which we are using, and the power on. So, for the turning on or the power on button on the PIC Sim Lab, that is a virtual software, we have to press the switch 5 for power on, and we have to press the switch 6 for either pausing or stopping it. Okay, and stopping would be long pressing the switch 6, and then we have the switch 4, which is used for navigation or to move from one mode to different mode. And then we have the switch 1, which is used to indicate the door status. Then we have the display, which will show the status of the washing machine on the CLCD. And we have a buzzer as well as a motor connected. Conclusion of the project and bibliography. So, the washing machine simulator project created an interactive interface using the PIC 16F877A microcontroller. So, the users can select different washing modes and water levels with the interface showing current status and time left. This project shows how embedded systems can make home appliances more user friendly and practical. Special thanks to Emertxe for providing the embedded systems internship opportunity and support. Now I am going to be showing you the simulation model of how it works. This is the PIC 16F877A microcontroller, and we are selecting the board from here. And after this, we are loading the hex file. It says that we have to press key 5 to power on the washing machine, and then we press key 5. So now the machine has powered on, and we can see that it has these daily heavy and whites, and we have to press the switch 4 for selecting what we want. We are pressing the switch 4 for a longer time for a particular option to get selected now. This is the next week, and after this is the water level, where you can see it's auto, low, and medium, the different modes available, and high. So we have various options to select the water level. We are pressing the switch 4 to select it for a longer duration of time. The switch 5, we have to press it to start, and then we are pressing the switch 5, and now we can see that the function of wash time is on. The timer is counting down. It again displays that you need to press 5 for start and the 6 button for stopping it. If we press switch 6, the fan stops, as we can see here. And then the function wash is stopped and the time has been halted. Now to start the program or continue, again the switch 5, we are pressing it. So again it is on, and then it indicates that the clothes are washing now. We have set a few seconds of timer, and we have to wait until the timer fully is completed, or the timer fully counts down to 0. When the timer comes down to 0, the washing machine will automatically stop, and it displayed that you need to remove the clothes. Again, now it has come to the first requirement. Sorry, the second requirement, that is the washing programs. It will come back to the same options which we saw before. A huge thank you to Emertxe Information Technology Private Limited for this wonderful opportunity and an excellent project in this internship. Thank you.